Here's the situation. This latest image from Thailand shouldn't appear this way. When you pass a comet through a Larsen second rotational gradient, you anticipate some symmetry, noise, perhaps a faint tail. What you observe here is neither subtle nor symmetrical. There's a bright, structured feature that is oriented directly toward the sun. It's not drifting, fading, or breaking apart. It's maintaining its shape and doing so consistently, frame after frame. Take a good look at the center. The inner coma isn't just a gentle glow, it is elongated. Something inside 3I Atlas is pushing material toward the sun in a manner that is atypical for comets. Even after observing for 2 weeks, the orientation remains unchanged, and the structure has not deteriorated. If this were merely artifacts from processing, we'd see the direction scrambled. If it were dust, it wouldn't maintain such coherence. And if it were solar pressure, it would point away from the sun, not toward it. So, right from the very first image of the night, the message becomes quite clear. Whatever is happening with 3I Atlas, it's happening again. It's becoming increasingly difficult to explain using normal comet physics. Now, let's compare the images from December 13th and December 14th side by side. When you examine them together, the pattern becomes impossible to overlook. On the left, the December 13th frame displays a small sunward feature that's tight. While it exists, it's faint and almost hesitant. The jet barely reaches beyond the nucleus, and the secondary structure on the opposite side is just a whisper. If you weren't aware of what you were looking at, you might confuse it for noise. However, the image on the right, captured merely 48 hours later, eliminates that uncertainty. The same structure persists, pointing in the exact same direction, but it is now stretched, brighter, and distinctly divided into 2 components. The main sunward plume is longer and sharper, while the counter feature is more robust, and the entire structure has expanded into a broader V-shaped geometry. Here's what stands out in the comparison. The direction has not changed. This isn't a random artifact. The axis aligns perfectly over 2 nights. The brightness has increased, indicating a true physical source gaining strength. Not just image noise. The structure has expanded, with the plume nearly twice as long in the December 14th frame. The symmetry has improved, with both sides of the feature now visible, not merely the primary plume. And here's the aspect that is challenging to reconcile with conventional comet models. Features like this are not expected to remain this stable. Dust fans rotate, gas jets wobble, viewing angles shift. But this feature holds its line like a fixed engine. 2 nights, 2 images. Same direction, stronger signal. Whatever 3I Atlas is doing, it's doing consistently. Next, let's delve into today's raw frames. The standard grayscale, the inverted view, and the color-enhanced map collectively narrate a story that the naked eye might miss. Begin with the left panel. The nucleus appears as a tightly focused point. No distortion, no breakup, no secondary peaks. If you simply examined this version, you might conclude that 3I Atlas is just another ordinary comet moving through space. No drama. Progress to the middle frame, the inverted grayscale. This is typically where subtle structures are revealed. Yet once again, the core remains remarkably compact. There are no signs of fragmentation, no fans spreading out, nothing that would elucidate the strange sunward features we observed in the rotation gradient images. Then you reach the right panel, the color-enhanced map, and everything changes. The outer halo lights up asymmetrically, with brightness distribution extending more toward the sunward direction rather than the anti-solar direction, which contradicts comet behavior. Typically, the most intense light should be observed opposite the sun, where dust is pushed away. Here, it's the opposite. The region facing the sun exhibits the excess signal. That contradiction, a tight core, a quiet interior, but a directional outer brightening, raises a significant red flag. If 3I Atlas were disintegrating, the nucleus would appear chaotic. If it were venting normally, the anti-solar tail would dominate. If the structure were mere noise, it wouldn't align across all three processing methods. But none of that is occurring. Instead, the core remains stable, almost stubbornly so. The halo is directed, but in the incorrect direction, and the color map confirms that genuine energy is being pumped into the sunward area. Something is consistently infusing momentum into that side of the coma, quietly and persistently, without disturbing the nucleus. That's not typical for comets. That's not how interstellar visitors behave either. Yet, 3I Atlas continues to do so. Now, let's shift to Italy, where Tony Scarato captured two new frames that align perfectly with those recorded in Thailand. These images were taken using entirely different optics, filters, and processing techniques. This is what makes it particularly intriguing. On the left, you have the raw, natural light-stacked exposure. Even without enhancement, the coma does not function like a simple fuzzy blob. There's a very faint forward brightening directed sunward that aligns with the direction seen in the Thailand data. No split, no asymmetric breakout, no fragmentation halo. Just a dense, stable core with a pushed forward glow. On the right, after applying a Larsen second rotational gradient, the structure becomes clear. The central pixel is extremely tight, measuring around 4,000 kilometers across at this scale. However, the real story lies in the narrow, bright extension that shoots sunward from the nucleus. It's not bending or dispersing like dust. It's focused. The tail points in the expected direction, away from the sun. But this feature points toward the sun, exactly as observed in the Thailand data from both December 7th and December 9th. Different country, different telescope, different night. Same structure. So, here's where we stand today. Multiple observers from various countries on different nights are all detecting the same forward-facing structure on 3I Atlas. A feature that shouldn't be this stable, shouldn't be this bright, and certainly shouldn't be consistently directed toward the sun. Something is propelling this comet, and whatever that is, it isn't acting like a typical interstellar comet. Now, I'd love to hear your thoughts. Is it merely an unusually active nucleus? A jet we've captured at the ideal angle? Or is 3I Atlas indicating something entirely different? Share your opinions in the comments. I read every single one, and if you want to track this object as it changes from night to night, hit like, subscribe, and share this video with someone who's been following the 3I Atlas saga. We're only just getting started.